Go for it, man.
Well done. Thank you.
Not right.
Thanks very much. You may have seen in the write-up of this that I wanted to be an astronaut. That's why I got an engineering degree. I watched Star Trek, Star Wars, all the video, and I wanted to see those alien life forms. And eventually I realized, one, I wasn't going to go to space, and two, the space has got such great views because in the vacuum of space, by definition, there is nothing. And I wasn't going to get to Jupiter or Mars, but I did realize that all the cool stuff that I thought was out there is actually underwater. And in fact, the filmmakers have figured that out as well. You have the creature from Alien, and you have something that looks a heck of a lot like the creature from Alien. You have, James Cameron has been quite clear that a lot of his inspiration for Pandora in the movie Avatar came from all of his submersible experience. He's one of the most, more deep dives than I have, so he's quite a skilled individual. But you look at this structure and then what it was like as he created it on Pandora. And then there are just amazing other creatures I started to realize as I started to focus on the ocean. This goblin shark that exists in the deep. One of my favorites is the barrel-eye fish. So the barrel-eye fish had been brought up in fish nets and things like that over the years, but until they saw it in its actual environment, they didn't realize that the eyes actually rotate up inside its gelatinous skull. So when it came to the surface, it was this blob, and nobody thought anything of it until they saw it in the real environment. One of the things, until the Malaysian Air Flight 370, I would say 90% of the people I spoke with had no idea what the average depth of the ocean was. They all thought it was sort of shallow, 1,000 feet, 2,000 feet. And the average depth's around 4,000 meters, 13,000 feet. And it is, one of the interesting things is you will get multiple answers if you Google this, because we have better maps of the moon than we have of the bottom of the ocean. So figuring out the average is sort of tough when you don't have a map of the bottom. But as you can see from this map, it's pretty deep. It's deep everywhere. If you look at and this is in meters. So I wanted to explore, and yet I didn't understand why weren't there more vehicles down there? Why when you have $600 billion per year of capital expenditures on ocean stuff, everything from oil platforms to pipelines to windmills to fiber optic cables, and tens of millions of billions of dollars on robots, why were there only 4 submersibles that could go to the average depth of the ocean? And one of the things, and it was declining. There used to be 6. So it didn't make a lot of sense in a growing market why one of the resources wasn't growing. And one of the things I came up with are the myths, and this will be about one of the 2 text charts that I'll have. One is that subs are dangerous. And the issue here is you have to separate research and commercial submersibles from military submersibles, which carry munitions and go to dangerous places. Research submersibles don't go in areas where the bottom of the area they're operating in is greater than the crush depth of the submersible, which is what really kills you. So that's one of the big differences. And in the last 35 years, there hasn't been a serious injury, and there have been over 15 million people go in them. Now, most of those are in tourist submersibles, but they're statistically the safest vehicles on the planet. The other one is that they're expensive, and they're expensive because nobody cared about cost. The subs that are out there, the deep diving subs, were built by universities, funded by governments to be statements of national pride and skill. So they were all about capability. Go the deepest, get the most samples, go deeper than the next guy. No thought to revenue, no thought to cost. And the other problem is they're big and expensive. And the cost of the sub is only a small part. It's really the ship. And so as it becomes bigger and heavier, you need bigger and bigger ships. And the word in the marine industry is your ship is always in the wrong ocean. If you're in the Pacific, you have a plane go down in the Atlantic, or something happens, there's a tsunami somewhere. So they're always in the wrong place. And so I wanted to figure out how can you operate and create a business, because if a technology doesn't have a commercial or military application, it doesn't tend to get adopted. And so what were the opportunities here? And there were multiple users of subs. The biggest being in the blue, and the big fat line is oil and gas. It spends over $15 billion a year on robotic services to service oil and gas platforms. But when you start with a new sub, they'll probably pay you to stay away from their facility. At the other end of this is what I call adventure tourism, but I'll elaborate on that. It's really, adventure tourism is the largest growing segment in the travel industry. It's roughly $270 billion a year. And the part of adventure tourism that is just trips that cost more than $100,000 per trip is over $4 billion a year. So there's a huge demand for travel that's different. And I took that and looked at some of the things like Earthwatch and other opportunities where people want to do something meaningful. They want to participate in the travel experience. They want to do something not just that's different, but that adds value that they are a contributor for. And looked at what I'm calling exploration travel, effectively. How can I engage these individuals to participate in some of the expeditions that we have planned? In the meantime, and I won't talk about what is exploration, obviously not here, but the issue of how people explore and how they fund it. I mean, funding of exploration activities is obviously one of the huge challenges. And here's a picture of Shackleton's crew, a pretty uniform group of hardy white men. Not a lot of funders in here, because the funder would fund it and get paid when books and talks were given. But it was there was a separation between those who supported exploration typically and those who participated in it. And you had some pretty rustic conditions. You think forward to now, where almost anyone can go to the Antarctic and go in reasonable comfort and do more adventure tourism than exploration. And the difference, I would say, is that the explorer documents what he does and goes with a purpose, as opposed to just going to create an experience. But a completely different experience than a century ago, which enabled me to think, okay, there are other ways to do this, other ways to fund this operation. And at the same time, you have technology changing. So just as scuba has come a long way from when Jacques Cousteau invented it, to the point where now, again, almost anyone can do it. And there's shockingly few scuba divers. As a diver, I thought there were a lot, but it's less than 1% of the population scuba dives. So it really, very few people do anything more than snorkel, and not that many people do that, quite frankly. This is Barton and Beebe, an interesting case of a funder and an explorer and an engineer actually participating in something together, which is really what we want to do. Combine those who have the means to expand our knowledge of the ocean. We've only explored 5% of the ocean. With those who have the vision and the desire to go do it as well. So this is just a sampling of subs that many of which can go to the depth that Beebe went to, around 1,500 plus feet. All of these subs are non-government subs. Actually, the one in the center is the Pisces sub. That'll go to 2,000 meters. But an interesting array of shapes and sizes. None of these go beyond 2,000 meters, so not even close to half the ocean depth. As I mentioned, there are only 4 that will do that. One is Alvin, which is the premier U.S. sub. A couple of years ago, Alvin had its 50th birthday. There are not a lot of pieces of high-tech equipment that celebrate a 50th birthday. Now, it has been massively upgraded. I don't know how much of the current Alvin was actually on the original Alvin. I suspect very, very little. But it is an interesting statement as to how much money has been invested or not invested in manned submersibles. This is the Shinkai 6500, which is the Japanese deep diving sub. Shockingly, it goes to 6,500 meters. The Xiaolong is the Chinese sub, came online a few years ago. It's currently the deepest diving sub on the planet, goes to over 7,000 meters deep. The Chinese are spending more than 10 times what we are on ocean technology and deep diving subs. Then you have the French Nautilus to 6,000 meters. But all of these are government owned. And for that reason, you can't use them for commercial operations except in isolated cases. The goal was, where do you want to go in the ocean? What is the most known site in the ocean? And it's clearly the Titanic. The story of it, the movies that have been made about it, it is so far above the next highest wreck, which I would argue is probably the Andrea Doria, that it's not even in comparison. And to go to the Titanic, which is at 3,800 meters, requires a special sub. And those were, in the past, there were missions that used the Russian sub. So back when the Russians needed money, they were selling off seats to space, they were selling off seats on the Mir subs, and a group called Deep Ocean Expeditions went in contract with them to go to the Titanic. They also went to the Bismarck. They actually funded the contract to go to the North Pole. These subs are three-man subs, three-person subs. They had two of them operating from a Russian ship. You would spend 2 weeks to get out to the Titanic. It was 24 people, and it was very much a tourist operation. There was no involvement. You were not meant to work on the sub or participate in it. You went in it, and you were, spam in a can. You won't find a lot of pictures of the inside of the Mir subs, as you won't on many of these things. That's why this one is so blurry. It's one of the few pictures I could find, because it's not something they really want to highlight. You get to look out a little porthole here with your two close friends, a Russian pilot and someone you probably just met on the ship. One of the things that people ask is, how do you go to the bathroom on a sub? In these research subs, they actually provide a curtain that you can put around your waist and a cup. So people tend not to go to the bathroom. When they did the Titanic expeditions, I asked, how did you guys deal with this? Because they were down for 10, 11 hours. And they said, we created a ritual. And the ritual was, before you got in the sub, you took a long, warm shower. And that seemed to take care of everything. And then we didn't give you a lot of water from there on out. Contrast that to the inside of our sub. So one of the things I did was I acquired an existing sub and we operated it, because the question I had was, how big should the sub be? How many people should you have? How long do people really want to stay down? How do you get them to and from the sub? What are the experiences they want? What are the other avenues to make money on the sub? And so we went through this and we created Cyclops 1, which is about 80% of Cyclops 2, which is the sub that'll go to the Titanic. One of the things we learned early on is that you have to have what we call a subject matter expert on board. Because I would go down and people would say, hey, that's a really cool fish. What is it? And I'd say, oh, that's a really cool fish. It's sort of like going to the Louvre if they didn't have labels on anything. It would be nice, but you wouldn't know what it was. And then when you go with a tour guide who's actually passionate about what you're looking at, it's a completely different experience. So you've got to have somebody who knows what you're looking at and can speak passionately to the subject. You have to have the pilot. And then who wants to go on the most life-changing event of your life alone? You want to go with your wife or your best friend or your child. So that means you've got to have 4 people. There are no 4-person deep diving subs. So if you're going to have 4, I figured to throw in 5. So imagine here, I've got 4 people in the picture, and I'm taking the picture from the back. So for filmmaking, it also helps, because now you have a depth of field where you can have 2 characters and the outside. You can create storylines that involve the inside of the sub. If you look at current pictures from subs, most of the time it's selfies of the people with as much wide angle as they can get, or inside-outside shots. So it's very difficult to create a storyline around that kind of a structure. So we made Cyclops 1. As I said, 80% of the same components. It has the same thrusters and control systems as our deep diving sub. It has the same life support systems. It has the same sonar systems. It has a fiber optic gyro inertial navigation system is the same. The big difference is on this one we had was an existing steel pressure vessel, which is good to 500 meters, 1,640 feet. On Cyclops 2, we did a whole series of projects with the Boeing company, with a company in San Francisco, in Sacramento called Spencer Composites that made a sub for Steve Fawcett before he passed away. And that's one of the big innovations. You'll see on the model outside, take the top off, there's a carbon fiber hull with titanium hemispheres on the end. We've done a great deal of testing on that. And that will replace this steel pressure vessel. But one of the things we wanted to do is that the vehicle is just a small piece of it. One of the big components I'll talk about in a little bit is how do you launch and recover this economically, and then how do you get enough public awareness so that you can actually have revenue and bring this thing online. And getting this out there was been a great success for us, being able to do things like dive on the Andrea Doria. We dove on Alcatraz Island. I think probably the first sub to ever do that, and do a number of sites. So launch and recovery. Your ship and your launch, which dictates your launch and Your launch and recovery system dictates your ship. And the challenge is, how do you join dissimilar loads in rough seas? Anybody can launch a sub when it's calm. But when you have 5-foot waves and you have a 20-ton sub and a 4,000-ton ship, they respond differently. And so how do you deal with that? Well, this is Alvin and Atlantis, its mothership. And you can see that's quite the A-frame. There's a whole bunch of stuff to try to dampen out this motion. And they still are not able to operate in very high sea states. This is Paul Allen's vessel, the Octopus, which one of the big features he wanted was the ability to launch a submarine. So he made a sub pen underneath. The bottom of the ship drops out like a James Bond movie, and his submarine Pagoo, which is a nice 1,000-foot capable sub, then comes out. The unfortunate aspect of this is the wave action, which they didn't plan, I guess, because this hadn't been done before, doesn't allow you to launch. The sub is, I think, 34 tons. And it comes up in the middle. Unless it's this calm, you can't launch it. So any waves at all, they can't launch the sub. Last year, the sub didn't dive. The year before that, I think it dove once. And Paul likes his sub. So it's a real challenge as to how do you do that. This was one of the best solutions to the problem, which is the TransQuest, which I think is still anchored off of, or moored off of Sausalito. And it was in the Cold War. It launched many of the Cold War subs. So there was the Turtle and the Mystic, and even Alvin, I think, may have launched from this. This back deck drops down. So it's a very ugly barge-like structure designed to be towed behind a destroyer at 22 knots. They then put some motors in it. And this whole deck here can handle 50 tons, and it drops down, and then the sub takes off. So it deals a little bit differently with the sea state problem. This is the Alucia. So this is owned by Ray Dalio, and it had been the Nadir, which was the launch ship for the French sub, the Nautil, that I showed earlier. He has 4 or 5 subs, several of which he keeps on the back deck. Great media ability. His company called Alucia Productions that did some work with David Attenborough on the Great Barrier Reef. And so it's still active and running around. But the real answer as to how do you join dissimilar loads in high sea states is you don't. You just rewrite this, and when I looked at it, the people who were doing it the right way were in Hawaii, at the Hawaii Undersea Research Lab. And what they do is they have the sub land underwater where it's calm. The worst place in the ocean, probably the worst place in the world, is where you have the air and the water meet. And so I like to say, in aviation, accidents occur when your altitude becomes negative. And accidents in the ocean occur on the surface. The accidents that happened more than 35 years ago, since I picked that as the safety point, were on the surface. So it's surface activity that is really dangerous. Do your difficult things underwater, and here they'd strap the sub down and bring it to the surface. They recovered a sub in 15-foot seas in this sea state. And those of you who have been to sea know how hard it is to make a picture of rough seas look really rough. That's incredible. And they were able to do it. And what they do is this comes to the surface, and instead of having the ships join up, one ship tows the other, and you use a Zodiac to go back and forth. So if somebody does get their hand caught between the support boat and the sub, it doesn't get crushed. And if they jump into it, they jump into an inflatable. So that was clearly the way to do it, but nobody was making new subs, and those that were being made, nobody wanted to try anything new. So what we didn't like about the Hawaii operation were 2 things. One, their platform was manned. It was its own submersible. So they had guys in scuba gear who would actually, what they call fly the bubble. They would get the buoyancy just right and keep it at 60 feet, and then 2 other divers would strap it down. And I don't think people should go in the water unless they're in an armored vehicle. You know, if you're going to go to Baghdad, do it in a tank. Don't do it with a flak jacket. And they had 2 occasions where they almost killed people, where they lost control of the buoyancy. And that was the key one I wanted to get rid of. And then the next thing they did was it can't be moved. It's too big. So we wanted all our equipment to be able to be moved on a standard truck in a standard container so we could get to the wrong ocean at the right time. And we could move these assets around. So if we could hit the quick video, I'll sort of talk about sort of how we load and unload folks here. So as I said, it's tough to show rough sea states. This is actually reasonably rough. This is a picture of when we went to the Andrea Doria. I think Renata, sitting in the front row, will soon have a starring role. And we launch it, we're actually, in Cyclops 2, it'll be done from the sub, so we won't have that surface guy in the boat who operates it. All the controls on this platform are pneumatic. There's no electrical components, so it's great for corrosion. Drops down. Turns out you don't have to go very far underwater to get away from sea states. The sub then takes off, goes and does its mission, comes in and lands, and we have a locking mechanism here where the pilot flies it in and locks it, so you don't need anybody in the water. And then we bring it to the surface. It can go under and up in less than 2.5 minutes each way, which is half the time the Hawaii sub operation system went. So as I mentioned, we did this Andrea Doria expedition last summer. We had a number of folks, Renata being one of them, one of the great values of this system being able to tow it is we mobilized in Boston, towed all the way around Cape Cod, did dives on the wreck, went into Menemska, transferred folks out, and then there was a hurricane last summer. It was one of the later hurricanes. I can't remember what its name was, but it stirred things up. This was in early June, first week of June. And we had 25-knot winds, 8-foot seas, and we had to call off the last cycle of dives. We're going to go back this summer and continue doing scans of that wreck. We're able to use, this is a offshore supply vessel, 120-foot ship out of Boston. You see no A-frame, no crane of any substance. We're able to do all this operation, service the sub. We run power over to it. We fill it with air and do all of that while it's at sea. So we went from, to show the mobility, we went from Seattle to Boston, mobilized in Boston, did these dives on the Andrea Doria, shipped the sub back to Seattle, shipped the sub from Seattle up to Desolation Sound, where we had a private client who I convinced you really need to get a sub at your house, and we brought the sub up there, and we baited for sharks. One of the things we found is if you just throw enough food out there, you will get sharks. And we got a bunch of dogfish sharks, which are about 5 feet long and pretty common. And then we took the client down, and we had been we dumped about 300 pounds of salmon in burlap sacks. We ran out of burlap sacks, and one of my pilots said, well, you got any old clothes? And I said, yeah, I got a pair of raggedy jeans. So he took the jeans and he shoved these salmon steaks into the jeans, and we sent it down. And if we'd hit the video, you'll see what we saw. So the jeans are 3 feet long, rough inseam. There's your dogfish shark being scared off by the six-gilled shark, which is about 14 feet long. It's a mid-sized, young adult. And the six-gilled shark is, hundreds of million years old. They are seldom seen. They seem to be everywhere on the planet, but they don't come up in the shallows. In Puget Sound, they breed. And so you'll find them this was at 500 feet down. Most of the time you don't find six gills till you get down closer to 1,000 to 2,000 feet. So then we went from British Columbia back to Seattle. From Seattle to San Francisco, we mobilized an expedition to the Greater Farallones Marine Sanctuary. Got, again, weathered out. So one of the things that's happened is every area, people, the locals, and everyone knows sort of what are the good seasons. So for the Titanic, the good season is May through August, historically. In San Francisco, having grown up there, everyone knows in October it's foggy and it's calm. Not this October. So last year, for the first 2 weeks, it was too stormy outside of the gate. And the Coast Guard sector in San Francisco is probably one of the best ones, I think, in the country. All the Coast Guard sectors have different cultures, I guess would be the right term. And we called them up and said, look, we'd like to dive on Alcatraz. With all the tour boats going in and out, they said, sure. So we brought the sub in and we dove on Alcatraz, did multiple dives, huge currents, as you would imagine. Our chief pilot is a Scottish gentleman who had done sub-rescue services and Royal Navy diver. And of course, he does the first dive on Alcatraz and he gets to the bottom. There's quiet. He sits down and he goes, welcome to the rock. But it was fun. It was fun for folks to go. And this ship here is not much of a ship. It's a drilling platform. It's a 109-foot flat bottom vessel, and we were still able to operate with that. So you were able to divorce this need for a a ship that can handle the big sub to you want a ship that can handle the seas you anticipate and house the people you want and house the equipment you need. You don't all of a sudden have to have one that's got this giant A-frame, of which there are not a lot on the planet. So all this work that we've done on procedures and training and public awareness and understanding sort of what the client needs are leads us up to Cyclops 2. And again, you can see it looks very similar. It's going to use the exact same fairing, same thrusters. It's just we have a titanium dome here. There's a carbon fiber hull in it, which I'll show you, and another dome in the back. The carbon fiber, this is the mandrel. This thing is 1.5 inches thick. That's a plate on there, but it's about 1.5 inches thick stainless steel. We just finished winding the 5-inch thick carbon fiber hull on Friday, and it now gets to spend 2 weeks in the hothouse curing. As I said, this is the winding. So it was we'd wind a layer, and then we do a longitudinal pre-pregged carbon fiber lay on top of this. This is commercial grade carbon fiber, and built it up to 5 inches thick. Carbon fiber in subsea vehicles is really the right substance to use. It's 3 times better on a strength to buoyancy basis than titanium, the next best thing. So everyone wants to use titanium, but it's not strength to weight that you care about, strength to buoyancy. So our hull is going to be positively buoyant, which is what you want in a submersible. If you look at those other subs, they're all big and fat, and that's because they have all the syntactic foam because they're too heavy. If you're light, it's a lot easier to add lead than it is to add foam. As I mentioned, you have the carbon fiber piece, which is finished. It was just out in New Jersey where we have titanium rings. This piece gets glued to the carbon fiber, and then this dome is how you enter and exit. So we have a big apparatus on the launch platform that opens, and you enter the sub and you close it. So entering and exiting is one of these big things. You know, the first thing you do in a sub, in most subs, you climb in a conning tower, which is very confining. It gets the total wrong feeling when you get inside, and then you don't have any viewports to look out. And then you sit on the deck of the ship for 15 to 30 minutes while they pick you up and launch you in a very passive fashion. So you start it in a relatively unpleasant way. You end the same way. You get to the surface, you're all happy, and then you got to wait a half hour while they get you on deck, and then you come out. With ours, you get this exciting launch off the platform, you get the landing on the platform, and you're in and out of the sub in a matter of minutes. So it really changes the experience. It also allows us to turn around the sub a lot quicker if we want to do multiple dives. As I mentioned, it's all about the Titanic. So we announced 2 weeks ago that we were going to go in May. The Titanic is so amazing. One of the examples of how amazing it is that there has been a number of websites that have advertised trips to the Titanic when they didn't have a sub, they didn't have a ship, they didn't have any hope or prayer of doing it. So when something is so great that people are willing to make up stories about it, that's a pretty iconic thing. We've been holding off, even though we knew we were going there, and we've brought some clients on board. We didn't want to go public until we had sold out the first year. And so we have 54 clients who are going to go for the first year, and we've started accepting folks for 2019. Our goal is to go to the Titanic every year until it doesn't make financial sense, to map it with the latest technology. We are working with the Advanced Imaging and Visualization Lab at Woods Hole to put photogrammetry on there, which allows you to generate 3D models using stereo cameras. We also have used sonar systems, but the visibility is quite good. We just reached agreement with company 3D at Depth that does laser scanning. So you can create a laser image quite rapidly that's almost as good as a photograph. And it doesn't just take the picture, it gives you this 3D model so that when we go back the next year, we can tell if the hull has decayed. So there's an argument out there. Some folks say that the Titanic's going to melt away in the next 20 years. Some folks say, no, those rusticles look worse than they are. They're mostly biology. There's not a lot of steel in them. So there's a bit of a conflict there. How shipwrecks dissolve at various depths, the Titanic, World War II oil tankers and the like, is not well understood. You know, it's dictated by oxygen content, pressure, biomass, currents, all kinds of things affect it, and there really hasn't been a lot of work. And it's a very critical subject. There are over 1 million shipwrecks since man started sailing. In World War II, over 7,000 ships went down with over 500,000 gallons of something on board. So they're all over the planet. And the question is, are these things going to break open and destroy beaches? There are two off of Long Island, the Coimbra and the Norvest, that the Coast Guard wants to go look at to find out, are they going to get silted over, encased in coral, or are they going to break open in the next bad storm? We're also able to use a different approach. This is the Keldysh, which is the ship that was used when you went on a Russian sub. I could not find any pictures of the inside of the Keldysh, not of their cabins, not of anything. So it must not be that great. I don't know. But it has been retired. It was a very successful, I think it was the largest research ship of its day. What we're able to use is standard offshore supply vessels. So this is a ship, and the oil industry in its boom days, which has declined a little bit, one of the things that happened was, particularly in the North Sea, people find out what the good ships are and what the bad ships are. And if you wanted to have the best workers for your oil platform, you better have a nice ship. The Norwegians know how to make a nice ship. So this vessel is about 90 meters long. It has a helipad, which we're going to use for transporting people to partway to the Titanic. So in the movie The Titanic, they show a helicopter bringing the woman out. That was done in the harbor because there isn't a helicopter that can do a round-trip flight to 380 nautical miles. What we'll use are S-76 Sikorsky helicopters out of St. John's. They can go a little over 200 nautical miles out, where they will rendezvous with this ship. The individuals will get off the helicopter, the ones who are leaving will get on, and then the ship will motor out all night to get to the Titanic's location. So it cuts several days off the trip, and those are several days that people don't want. Pounding through the North Atlantic doing nothing is not really what folks came for. A little tidbit, this thing here, speaking about how they've tried to make working better, this ship currently is servicing a lot of windmills in the North Atlantic. One of the challenges when you go to service an oil platform or a windmill is if you're sleeping on this vessel, which has 56 cabins and has 90, it can take 90 people, is to go to work, you have to get up, you have to put on, we call it Gumby suit, survival suit, hop in a boat, drive over to the platform, take off your Gumby suit, go to work. This is referred to as a walk-to-work vessel. This platform is dynamically, the ship can be dynamically positioned, and this can dynamically be loaded onto the platform. So the individuals walk out, they walk up the stairs, they walk to work, they walk back. It's a big benefit, which means you get the best workers. Another shot of how, here's your walk-to-work platform. This boom can lift 150 tons. And being Norwegian, it's quite nice. So you look at the vessel is 4 years old. Very important to have hospital facilities. One of the questions about this is how risky is going in the sub. Turns out in this expedition, probably the safest thing will be once you're underwater. Once I'm a couple of feet underwater, I know I'm coming back. I know everybody's coming back. It's getting in and out of the sub. It's getting to the ship. It's taking that helicopter training. Everyone who comes out will have to take helicopter underwater egress training, where they put you in a mocked-up helicopter cabin and dunk you in a pool, and then you got to get out. And you got to get out with a survival suit. So that's where the real risk is. It's getting to the location. It's not the location itself. And of course, again, a nod to the Norwegians. It has its own sauna. The cabins are nice workout rooms. There are all kinds of great amenities, so it doesn't have to be uncomfortable to do exploration. Before we do that, as I said, we're going to go back to the Andrea Doria. We're going to do it in a slightly different fashion. Last year, it was a 3-day mission, so you spent a lot of time on the boat getting back and forth from Menemcha. This year, we acquired a rapid response boat surplus out of the Coast Guard. So these are the 25-foot boats some of you may have seen if you didn't have the license and registration on your vessel. But they can do 35 knots. You strap in hydraulic seats so you don't lose your kidneys, and we'll motor out, take people out in 2 to 2.5 hours, come out to the ship, spend the night, dive back in Nantucket by the evening. So a quicker trip, which translates into more people who have the means to do it are more excited about going there. And it allows us, working with Woods Hole, to be able to use some of these systems, the photogrammetry and with 3D at depth, to look at laser scanning and to continue to develop the operational profile for the Titanic. After we do the Bahamas, no, sorry, after we do the Andrea Doria, we're going to take the sub down to the Bahamas, where we've reached a partnership with the Cape Eleuthera Institute, which is associated with the Island School, and they also run a middle school, and they have a resort down there. It's a great location, and within about 3/4 of a mile from their marina, it drops off down to about 3,000 meters from 100 meters. What they want to do is investigate the interaction between surface sharks, the reef sharks, black-tip sharks, and the like, hammerheads, and the deep sharks like the six-gill sharks. So it's been known that the six-gill sharks will come up to as shallow as 300 meters, unless they're in Seattle, and the surface sharks will go down to around 500 meters. So the idea is they will put out bait stations and see what the interaction, who becomes the dominant shark, put GoPros on that, and then we will have clients come down and be able to go observe the interaction, bring the bait back up, and the GoPros put another set down, and see what that interaction is like. It should be a very exciting trip, and it also puts us in an area where most people think about operating subs. One of the best places to dive a sub is in the Puget Sound area in Seattle, but no one thinks about going underwater in Seattle. It's a pretty tough sell, even though I can tell you it's the best diving probably on the planet. Jacques Cousteau said it was the best diving on the planet. They've got deep sea corals, they're just great stuff, but people just don't think about it. They think about diving like they think about snorkeling. If it's not warm, I don't want to do it, even though it doesn't matter when you're in the sub. So when we're being in the Bahamas will allow us to do other projects. There's a grouper spawning. There are a variety of other activities that research organizations want to do. So if we can get the clients to sort of justify us bringing the sub there, research projects, whether it's expanding marine protected areas and making those visible to the public, other projects will be available. And so that stub will stay there for a year while we're gearing up with Cyclops 2 to the Titanic. What do we have on the horizon for other stuff? Well, Deepwater Horizon is one of them. Going back and seeing that, it's relatively shallow. I think it's about 1,500 meters. Seeing what that looks like. There's some question as to is it leaking or not. I think there would be a lot of individuals who would like to go to that. It's relatively easy to get to. This is the Indianapolis. NOAA did a survey of that. Bob Ballard did that over the summer. They're not going to go back, but it would be a great wreck. It's one of the few ships to survive an H-bomb attack. So it was in the Bikini Atoll and then brought back to San Francisco, and then they went and sank it, but they sank it a little shallower than they expected. It's in about 900 meters of water. It was supposed to be, off the shelf. I think they also put some chemical, some nasty stuff in there. It used to be the way to dispose of things was just dump them in the deep. One of the projects we want to do is the Battle of the Coral Sea, where the Lexington sank and a Japanese aircraft carrier sank within a few miles of each other. It was the first all aircraft carrier battle. One aircraft carrier group against another. Those wrecks were located accurately a couple of years ago. NOAA and the Australian Navy have gone back and done some work on them, but it should be a very exciting site. A lot of history there, a lot of airplanes that are down, as well as the vessels themselves. And we can go and bring this new technology and scan those wrecks as well. So what is the condition? How does it change? Create the historical record. So that as these things decay away, we at least have some idea, what parts, were destroyed first and how they've survived. My personal favorite are hydrothermal vents. That's what I wanted to do. That's where the really weird life forms are. And for those of you who aren't aware, this is a whole ecosystem not based on photosynthesis, based on chemosynthesis. I think I got that out. Highest density of biomass on the planet are around hydrothermal vents. If the sun went out tomorrow, these guys wouldn't know it until the ocean froze over. So they're living off of the energy from these vents. There are over 1,000 of these sites identified. They're probably 10 to 100 times that, up and down the mid-continent ridge, all over the planet. And these are the weird creatures I want to see. Yeah, these giant tube worms, that 3 feet long. It's all, and these are based on sulfur and just totally different life forms, all existing in a very interesting area between the water, which is normally at about freezing temperature, and 300 degrees centigrade is what comes out of these vents. And they live in this environment, and live and multiply. So, and each of these vents are their own ecosystem that live for only a matter of years before they go off into the currents and have to find a new vent as the vents die. Things like the Lost City, where they have 7-story high towers of these vents that I think would just be very exciting to explore. One of the things I realized was, had I known what was there in the ocean, and had that been popularized with movies that weren't Das Boot, or, you know, I'd say The Abyss is probably the best of the genre, but if there had been things like Star Trek, you know, there was Johnny Quest, there was Jacques Cousteau, there were pieces of it, but it didn't take off like space did. It doesn't have the visuals. That's it may have the facts, but it doesn't have as much of the emotion. It feels freer to look up than it does to go underwater. Half the people I talk to say there's no way I'll ever go in a sub. Humans are naturally terrified of going underwater, but it is where all the cool stuff is. And what I wanted to do was to take all this cool hardware that's out there and these stories that our pilots have about going in the subs with other operators or with us, and bring them to kids so that they can see that there is all kinds of opportunity and reasons to pursue a STEM education that are sort of out of the norm. And in fact, in the ocean space, you can have a very good job as a remotely operated vehicle operator. Without a college degree, you can make over $100,000 a year. I mean, these are opportunities for really good living, and wanted to expose that. So the OceanGate Foundation supports the company, and the company supports it. When we go to a location, for example, when we do the Andrea Doria again this summer, we'll do an outreach event where the foundation will pay to bus kids in from underserved schools and have them see the sub and talk to the pilots and hopefully inspire the next generation of explorers. And they like it.